Hello, in this video, we are going to discuss how to solve trigonometric equation. Now, remember when you are solving an equation, you want to say a variable is equal to some number. In this case, a trigonometric equation is just a simple equation that involves trigonometric functions. So all the methods that you know on how to solve linear equations, quadratic equations, exponential equation, and any equation, you are able to apply it on a trigonometric equation. Okay, and our task here is to say theta is equal to some angle, which will be our desired number. Let us quickly look at few examples. These are real exam problems. The first one says 2 sine cubed theta minus sine theta is equal to 0. And we are going to choose only angles between 0 and 2 pi. So when you look at this equation, we can factorize it, right, by factoring out sine theta. That is the first step. So let us go ahead and factorize sine theta. So this is sine theta. When we do that, we remain with 2 sine squared theta minus 1 is equal to 0. Okay. Now, using the zero product principle, this is sine theta is equal to 0, or 2 sine squared theta minus 1 is equal to 0. Okay. Now, we can focus first on the first one. Okay, we said sine theta is equal to 0. Now, you know that for you to calculate this angle, you could say theta is equal to sine inverse of 0. Or we can use this table. So therefore, theta is equal to 0. You know that sine 0 is 0. And theta can be pi and theta can be 2 pi. So this is the first set. Okay. Now we have 2 sine squared theta minus 1 is equal to 0. So we can factorize this by using the difference of two squares. So we can write as I call this star, so we can write star as the square root of 2 sine theta minus 1. Okay, so you can see that the square root of 2 multiplied by the square root of 2 gives 2, which is a 2 here. Then if you multiply this multiplied by that, and this multiplied by that, these are the square root of 2 sine theta is going to cancel out with this one. Then negative 1 multiplied by 1 is 1. So this equation I've named star is equivalent to this underscored equation. So this implies we can solve for sine theta. So from the first one, we have sine theta is equal to, you know that this will be positive 1 divided by the square root of 2. Okay, or from the second one, we have sine theta is equal to, so this will be negative 1 divided by the square root of 2. Okay, now what we are going to do is very simple. Let us try and see if we can represent this solution on a simple diagram. In the first quadrant, all trigonometric ratios are positive, or sine is positive, cosine and tangent. And then here only sine is positive, tan is positive, and cosine is positive. Now we have sine theta is equal to 1 over the square root of 2. You can rationalize this, and this is just the same as the square root of 2 over 2 by multiplying by the square root of 2, both the numerator and the denominator. And you know that only angle 45 gives us this number. Okay, so using the table of values, or using this table of values, you can see that sine pi over 2 is equal to root 2 over 2. So therefore, theta is equal to pi over 4, okay, which is 45 degrees. Okay, so we have pi over 4, but remember pi over 4 is in the first quadrant. So we have to look for the corresponding angle in the second quadrant. Okay, why are we looking for the corresponding angle in the second quadrant? Because sine is positive. Okay, so sine is positive here and sine is positive here. Okay, so angles in the second quadrant, we are going to say this is pi minus uh, pi over 4, and this angle is 3 pi over 4. So we have pi over 4 and 3 pi over 4. Okay, now we are done with uh, sine theta, which is positive, this number, in the first quadrant and in the second quadrant. Or we can say theta is equal to, now we have sine theta is negative, this number. Okay, and remember this is the same angle, it's just that this is a negative angle, and we know that sine is negative in the third quadrant and in the fourth quadrant. And how do we find the angle in the fourth quadrant? We are going to add. So the first angle will be pi over 4. That is the angle in the first quadrant, plus 180 degrees, which is plus pi. And this is 5 pi over 4. Okay, so we have 5 pi over 4, the first one, and the last one is in the fourth quadrant. So in the fourth quadrant, we're just going to remove this angle here. Okay, that is pi over 4. So this will be 2 pi minus pi over 4. And this is equal to, that is 8. So this is 7 pi over 4. Okay, so what is the conclusion? So the conclusion is, given this equation, 2 sine cubed theta minus sine theta equal to 0, on 0 to 2 pi, the first angle is 0, then pi and 2 pi. That is the one that gives sine theta equal to 0, 0, pi, and 2 pi. Okay, then after using the difference of two squares, we ended up with that. And sine theta is positive, so for the positive values, we have pi over 4 and 3 pi over 4. And for the negative values, we have 5 pi over 4 and 7 pi over 4. Very good. Let us look at the second question. The second question demands a general solution. And it says 2 sine squared theta is equal to 5 cos theta minus 1. But we have a problem here because we have two different ratios, sine theta and cos theta. So we are going to make a common trig ratio. Okay, so you would want to recall that sine squared theta plus cos squared theta is equal to 1. All right, which implies that sine squared theta is equal to 1 minus cos squared theta. So we can go ahead and substitute, meaning that the given question becomes 2, open parenthesis, 1 minus cos squared theta is equal to 5 cos theta minus 1. Okay? So when we expand using this distributive property here, the parentheses, we will end up with 2 cos squared theta plus, that is 5 cos theta minus 3 is equal to 0. Okay. Now, having done this, we can solve this equation. Now, to make things easier, I am going to say let t be equal to make things easier, I am going to say let t be equal to cos theta. So this equation becomes 2t squared plus 5t minus 3 is equal to 0. So we can factorize this quadratic equation. And if we solve this quadratic equation, we have t is equal to negative 3, or t is equal to, that gives 1 over 2. Okay. But remember, we said t is cos theta. So therefore, cos theta is equal to negative 3, or cos theta is equal to 1 over 2. Now let us start with the first equation. The first equation says cos theta is equal to negative 3. Okay, but you would want to remember that cos theta and sine theta lies between 1 and negative 1. So meaning that there is no angle that satisfies this equation, because negative 3 is beyond the range of cosine theta. The remaining one is cos theta equal to 1 over 2. Looking on our table or having memorized this, we can see that this is theta is equal to pi over 3. Okay. Now, since cos theta has 2 pi as the period, so the general solution, we are going to add plus 2 pi n. Okay. But one thing that we need to remember again, from the previous question, we had something like that. So all the ratios are positive here, sine is positive here, tan is positive here, and cosine is positive here. So since cosine is positive in the fourth quadrant, the second solution is going to be theta is equal to 2 pi minus, we are going to reduce it by pi over 3. Okay, but we need to add the period, that is 2 pi n. And what is that? So 2 pi minus pi over 3, this is 6, which is 5 pi over 3. Then we are going to add 2 pi n. So this is the general solution. Let us look at the last equation. So interesting. We have cos squared theta is equal to 4 sine squared theta for theta between 0 and 2 pi. So first of all, let us write cos squared theta minus 4 sine squared theta is equal to 0. So again, we can use the difference of two squares, right? So we can write this as cos theta minus 2 sine theta. I'm just factorizing, and this is cos theta plus 2 sine theta is equal to 0. So what did I do? I just factorized this thing, okay? So if you want, you can change cosine squared theta to 1 minus sine squared theta and then simplify. But I just decided to use this different method, okay? What does this tells us? This tells us that cos theta minus 2 sine theta is equal to 0, or cos theta plus 2 sine theta is equal to 0. Let us start with the first one. So we can say this is cos theta is equal to, this will be 2 sine theta. We can divide throughout by cos theta, so therefore this is just 1 is equal to 2 sine theta over cos theta. But we know that sine theta over cos theta is tan, so this is tan theta is equal to, we can divide throughout by 2, this is 1 over 2. Okay, in the similar way, we can say this is 2 sine theta is negative. Okay, and again we can divide throughout by cos theta. Okay, so our equation, which was cos squared theta is equal to 4 sine squared theta for those angles, reduces to tan theta equal to 1 over 2 and tan theta equal to 1 over negative 2. So this question, the last question, demanded one to use a calculator in the engineering exam, and in this course I'm not using a calculator, so I will leave it here. You can check angles on a calculator that gives you 1 over 2 and negative 1 over 2. Thank you for watching. Please share and like for more videos.